In the last lesson, we looked at how to reduce rational expressions. Now we're going to multiply and divide rational expressions. The good news is those two lessons are almost exactly the same. Let's just review on how to multiply fractions. When you're multiplying 10 over 21 times 4 over 5, that's 14 over 5. One way you could multiply straight across, then you get these big numbers that then you can end up reducing. And let's see, and you could say 5 goes into both of those and get that answer. The easier way to do this problem is to reduce along the way, meaning 5 and 10 have a common factor of 5. 5 goes into 5 there one time, 5 goes into there two times. 21 and 14 have a common factor of 7. 7 goes into 21 three times, 7 goes in there two times. So now I can multiply straight across and get 4/3. To me, that's a whole bunch easier than trying to divide or reduce those bigger numbers. Now, how do we divide fractions? Well, in order to divide fractions, you have to change it to multiplication, and we're going to multiply by the reciprocal of what you were dividing by. And again, you could just multiply straight across or reduce along the way, reducing common factors. And then we say, that's 6 over 1. That is exactly what we're going to be doing with our rational expressions. It says to multiply or divide as indicated, and we're going to reduce. In reality, we're just going to be reducing because we're going to factor the numerator and denominator, and we're going to divide out common factors. If you go back and look at the notes from the last lesson, these are exactly the same two steps we had. Factor and then divide out common factors. So let's look at number 1. Well, you cannot do anything with that because it's a monomial. So I'm going to leave that as it is. This is a binomial that we can factor. We can take out a 5x. And then because this is division, we're going to change it to multiplication of the reciprocal. So that's going to go on the bottom. And then this is going to go on the top. Its common factor is 10x squared. Now we look for common factors in the numerator and the denominator. And yes, 2x plus 1 is in common, but we have other things as well. We have x's and all kinds of things. So let's see, 3 and 12 reduce, 5 and 10, and we have all those x's. So I think I'm going to take a couple of steps to kind of clean up my answer. So first of all, I know those divide out to 1. 3 goes into 12 4 times. 5 goes into 10 2 times. This is where you have to be really careful and not get too messy. So 4 times 2 is 8. Then I have x cubed times x squared is x to the 5th. And then I just have y squared. Look to make sure, did I skip anything on top? Did I leave anything else out? I don't think so. On the bottom, I've got x squared. Remember, you keep your base and you add those exponents, and y. Is that my final answer? Are there any other common factors I can reduce? Yes. Okay, so we can use our rules of exponents when we divide. Keep the base, subtract the exponents. Keep the base, subtract the exponents. All that messy problem comes down to 8x cubed y. So did we really ever multiply? Well, a little bit, I guess 4 times 2. Did we divide? Yeah, a little bit here and there. Mainly it is factoring and dividing out common factors. So now let's look at number 2. Well, I can't factor that, so I'm going to put it in parentheses to remind myself that is indeed a factor. Here, that has a common factor of 4x. This is multiplication, so I keep it the same. What do those have in common? I think an 8x squared and that would leave x plus 6. Here, 7 divides both of those, so that would leave 2 minus x. Now I look to see, can I reduce any common factors? Well, 4 and 8 are both divisible by 4, so they have something in common there. I can reduce those x's because those are factors, they are being multiplied. But what about x minus 2 and 2 minus x? Are those exactly the same? No, but you should remember from the last lesson that they are opposites. So when I divide those out, it's going to leave me a factor of negative 1. Let's go ahead and reduce the others. 4 goes into 4 one time, 4 goes into 8 two. X divides x squared, that leaves an x. Remember, keep your base, subtract the exponents. So on top I have negative 1 times 2x times x plus 6. On the bottom I have 1 times 7, which is 7, times x plus 3. Now you could leave your answer like that, but I want to make it a little bit prettier. Usually you don't write a negative 1. Let's just write negative 2x times x plus 6 over x plus 3. I think that looks a little better. So we have to know how to factor. We need to know about opposites. Alright, number 3, we're multiplying, so we don't need to take the reciprocal. We have some more complicated kinds of factoring. That's a trinomial. It doesn't have a coefficient of 1. So 3, let's see, the 3, I can only use 3 and 1. Now 8, I could use 8 and 1 or 2 and 4. Let's try the 2 and 4. Take a minute and see if you can factor this. Did you get it right? Did I get it right? If I multiply that out, do I get negative 10x in the middle? Yes, I do. Okay, let's do this trinomial. Again, it doesn't have a coefficient of 1, so I only have 2x times 1x. For 4, 2 and 2, or 4 and 1. Now why can't I use the 2 and the 2? Because I cannot put a 2 with a 2 in a parenthesis. That's never going to work. So I know it has to be 4 and 1. And where can the 4 not go? The 4 cannot go with the 2 because they have a common factor. So it needs to go this way. Check out the signs. I think that needs to be negative and that needs to be positive to get me a negative 7 in the middle. Now let's keep going. I have this trinomial. Good news is I only have one choice for 5, 5 and 1. Everything's positive. You put it where you think it should go. Does that give me an 11x in the middle? Yes, it does. On the bottom, the difference of two squares, a little bit easier. So I know 3x times 3x, 2 and 2, and they need to be conjugates. So, do I have any like factors or opposites on top and bottom? Well, x minus 4s, those are the same. 3x plus 2 and 3x plus 2 are the same. What else do you see? I see 2x plus 1 and 2x plus 1. Alright, so let's start reducing. So what happens? That divides into one time, that goes in there one time, that goes in there one time. So all I have left on the top is 1 times 1 times 1 times x plus 5. And on the bottom, 1 times 1 times 1 times 3x minus 2. A lot of factoring and reducing. Okay, last example. That is the difference of two squares. So the 4 comes first, the x comes second. They need to be conjugates. Got that trinomial. I know I need 2 and 1. And for 9, either 3 and 3 or 9 and 1. Let's try the 3 and the 3. And everything's positive. Does that give me a 9x in the middle? Check that out for me. I think it's okay. Now I need to change this to multiplication, so this goes upstairs. So for 4 I have 2 and 2 or 4 and 1. For 21, 3 and 7 or 1 and 21. I'm going to look at the rest of the problem, and I have a bunch of 2's, so I'm going to try 2 and 2. And remember, I'm moving this upstairs because I'm taking the reciprocal. I'm multiplying by that reciprocal. And then I'm going to try the 3 and the 7. All pluses. Does that get me 20 in the middle? Yes, it does. Okay, now I'm going to try this last trinomial. Again, 2x and 1x. 14 is either 1 and 14 and 2 and 7. But since the other one had a 7, I'm going to try the 2 and the 7. I need to get a 3 in the middle. Take a sec. You put the numbers in. Well, if I use the 2 and the 7, the 2 can't go here because I already have a 2. I need a positive 3, so it means my bigger number needs to be positive, and I need to multiply to get a negative. Again, I think that works. Now I'm going to look for common factors. Let's see. 2x plus 3, 2x plus 3, 2x plus 7, 2x plus 7. What about this? Or should I use that one? Look and see. Well, I know that divides out to 1, that divides out to 1, but x minus 2 and 2 minus x are opposites. So, not opposite, but this one is the opposite. So when I reduce that, I get a negative 1. So let's see what I have left in the numerator. I have negative 1 times 2 plus x. In the denominator, I have x plus 3. And again, that is an okay answer. I'm just going to rewrite it without the 1, but definitely keeping that negative sign.